Hi and welcome to feyn-lab lectures. In this lecture we'll be talking about the conservation of momentum and we'll recall what we have learned in the previous lecture about the linear momentum. So actually the previous lecture we were discussing about the linear momentum of the system of particles. So the linear momentum of the system of particles, this is the a solid body, a rigid body. So there is this, it's made up of many particles, millions and billions of particles, and to calculate the movement of the individual particles, what you do is you just simply take the momentum of the individual particles and you add up vector addition in a sense, and then you get an answer, and that is nothing but the momentum. So the momentum can also be written as system. The momentum of a system as a whole can be calculated with this formula. The P, the moment of the system, is equal to the total mass of the system times the velocity of the center of mass. So that gives you the momentum of the system. So we discussed this in the previous lecture. So what we shall discuss now is the conservation of linear momentum. Again, linear momentum, momentum is of two types, the angular and the linear momentum. The angular momentum will be discussed later after the rotational body dynamics, but not, we shall discuss only about the linear conservation of the linear momentum. So for conservation of linear momentum to be applicable, there are two things that you need. The first thing is that the momentum, the body or the system that you consider has to be closed and isolated. So only if the body is both closed as well as isolated, then the principle of the conservation of momentum is applicable. So, so how do you write the same for the same equation? Let's say the body has some kind of axis or something, rigid body, so it must have an axis. So if no net external force acts on the system, then the momentum or the linear momentum of the system does not change. So if there is no net force acting on the system, then the linear momentum of the body does not change. The total linear momentum cannot change, or the initial momentum of the body is equal to the final momentum of the body. So there is no change at all in the the momentum of the body. So here again one special case. Say if there is this one of the components of the external force, there is this F external force in this direction along the axis is constant. If F external force is constant along this axis, then the linear momentum along this axis is also constant. Again, the conservation of linear momentum holds good if the external force acting along the axis is a constant. So again, the same if the if the component, the external force, the external force along the axis or along an axis, again in a closed and an isolated system, then the component of the linear momentum, along the same axis is also a constant, or it doesn't change. Alright. So I think this sums up the lecture of the momentum, the linear momentum, the conservation of the linear momentum. We've discussed about the conservation of energy. It's actually the straight body dynamics has come to an end. From now on, the things get a bit complex when we discuss about the body moving in rounds as well as rotating and so on. So it gets a bit complicated, but I wouldn't say complicated because I'm a human being. I'm also a rigid body, in one sense. Unless I stretch my arms and then you have certain restrictions, such as not stretching the arms. So I'm a rigid body, like I'm standing. So I rotate, and this is what I do every day. So the rotational body dynamics may seem complicated, but it is just complex. It's not complicated. It's physics, and it's around you, and it's very easy if you can understand. So it's goodbye from me again. Thanks for watching the lectures. I hope you keep supporting the same way, and thank you very much for everything.